All right, so going over section 1 of the review. First, we have graphing log base 2 of x minus 3 plus 2, and it wants us to graph at least 3 points and the asymptote. So first, we can figure out what the asymptote is based off of our horizontal shift here, which is this right 3. So I know that I'm going to have a a vertical asymptote at x is equal to 3. So we can go ahead and write that x is equal to 3. Then I'll go ahead and draw the asymptote. So at x equals 3, we'll draw a line there. All right. Then I'm going to go ahead and get rid of all my transformations and just write out my log function here, which is just going to be y is equal to log base 2 of x. Again, I'm taking away the horizontal shift to the right 3 and the vertical shift up 2. And I'm going to find the inverse of this, which is going to be x is equal to log base 2 of y. And then I'll convert that to an exponential. So I'll have 2 to the power of x is equal to y. And I'm just going to go ahead and make a quick table for that. So that is going to be my x and my y values. Let's just do -1, 0, 1, and 2. So that would be 1/2, 1, 2, and 4. All right. So now that I have all of those values, I'm going to go ahead and swap my x and my y values in a second table. So now my y values will become my x values. So 1/2, 1, 2, and 4. And then my y values will now be my old x values of -1, 0, 1, and 2. And then now I'm going to bring back in my transformations from earlier. So a horizontal shift to the right 3, I'm just going to add 3 to all of my x values. So by doing that, that will be 3.5, 4, 5, and 7. And then for all of my y values, I'll apply my vertical shift up 2. So I'll add 2 to all my y values, which will be 1, 2, 3, and 4. So again, I'm going to go ahead and plot all of my points. So I'll have one right here. I'll have one here, one here, and then lastly, I'll have one at 3, 4, 5, 6, 7, up 4 here. So then my log function should look something like this. My domain will be going from my asymptote to infinity. So that would be from a +3 to infinity, where 3 is not included. And then my range is going to be all real numbers because the range for logs will be all real numbers. All right. Moving on to question number 2. For some base b, it is known that log base b of 3 is equal to 1.2. What is the value of log base b of 27? So I go ahead and I'm going to convert log base b of 27 to log base b of 3 to the power of 3. I'm doing that because I see, based off what's given to me, that I have a base of 3 right here, and I can rewrite 27 to be having a base of 3. So I'm now going to move this 3 to the front using my log properties, using the power rule here. So that's going to be the same thing as 3 log base b of 3 is equal to, or not equal to anything. Okay. So then now, again, we know that log base b of 3 is equal to 1.2. And right here, I have log base b of 3. So I can just go ahead and plug in a 1.2 for that. And I know we're going to have 3 times that. So in the end, we know that log base b of 27 is just going to be equal to 3 times 1.2, which is 3.6. All right, moving on now to number 3. It says the population of a bacteria colony is rapidly increasing. If the population P of T, represented in millions, can be modeled, by p of t equals 6 to the power of log base 4 of 3x plus 7, where t represents the time in years, when will the population of the bacteria colony reach 216 million? And we also are going to want to go ahead and simplify our answer as a number. All right, so the first thing you want to do here is go ahead and set up our whole entire equation here. So we know it's 216 million. Now it says also that P of T is represented in millions. So what I'm going to go ahead and do is I'm going to set 216 equal to 6 log base 4 of 3x plus 7. And then 216, that can be rewritten now as 6 to the power of 3 is equal to 6 log base 4 of 3x plus 7. And again, that's because we know that we know that we want a log base of 6 because we want a base of 6 because we have a base of 6 over here in our given equation. So now that my bases are equal to each other, I can go ahead and set my exponents equal. So now I get to solve 3 is equal to log base 4 of 3x plus 7. And now I'm essentially just going to solve this by converting this to an exponential here. So I'll do that on this side. When I convert that, it's going to be 4 to the power of 3 is equal to 3x plus 7. 4 to the power of 3 is equal to 64. So 64 is equal to 3x plus 7. I subtract 7 from both sides. So 57 is going to equal 3x. Divide both sides by 3. So in the end, x is going to equal 19. So our final answer is it will take 19 years. Number 4 here, we're just solving solving an exponential here, and we're going to put our final answer in common log form. So I'll just rewrite that first. 8 to the power of x minus 2 plus 14 is equal to 123. I subtract 14 from both sides, so 8 to the power of x minus 2, that is going to equal 109. So now that I have this, I'm going to convert this to log form. So that will give me log base 8 of 109 is going to equal x minus 2. Add 2 to both sides. So I'll have log base 8 of 109 plus 2 is equal to x. And then, because I want my answer in common log form, I'm going to go ahead and now convert this using change of base. So my final answer should be x is equal to log 109 divided by log 8 plus 2. All right, number 5 here, I'm solving the natural log of x to the power 7 minus the natural log of x to the power 5 is equal to 6, and I'm stating any extraneous solutions if we have any. So I will have the natural log of x to the power 7 again minus the natural log of x to the power of 5 is equal to 6. So the first thing I'm going to do here is I'm going to apply my quotient rule because I'm having two logs with the same bases subtracted from each other. So that's going to be the same thing as a natural log of x to the power of 7 divided by x to the power of 5 equals 6, which essentially is just the same thing as the natural log of x to the power of 2 is equal to 6. And again, a natural log is just a log with a base e. So I'm going to rewrite that as that there. And now I'm going to convert this to exponential form. So I'll have e to the power of 6 is going to equal x squared. Then I go ahead, I take the square root of both sides to get x by itself. So x is going to be equal to plus or minus e to the power of 3. So if I have plus or minus here, I just want to make sure that either both of them will work. Now, if I go ahead, though, and I plug in, let's say, negative e to the power of 3 into my first natural log, so natural log of negative e to the power of 3 to the power of 7. When I go ahead and I do that, that will still give me a negative e to the power of 21 now. And again, we can't have a negative inside of an argument of a log. So negative e to the power of 3, that would be extraneous. So the only real solution that we'll have is going to be x is equal to e to the power of 3. All right, so now we're going to find a numerical value for y equals log base 5 of 125 times the fourth root of 5. So I'm going to convert this one first to exponential form. So we'll do 5 to the power of y is going to equal 125 times the fourth root of 5. Now, seeing I have a base of 5 on the left should be my hints here. So that will tell me 5 to the power y is equal to 125, which can be rewritten as 5 to the power of 3 times the fourth root of 5 is the same thing as 5 to the power of 1/4. And now I have all of the same bases here. But if I use my product rule, if I multiply together 5 to the power of 3 and 5 to the power of 1/4, I'll just add my exponents together. So that's the same thing as 5 to the power of 3 and a fourth, or in other words, 13 over 4. And in the end, I'll get y is equal to 5, not 5. Y is equal to 13 over 4 because my bases are the same. I set my exponents equal to each other. For number 6, I'm going to find the inverse of this function here and find the domain of the function that I found. So I can now write this as x is equal to e to the power of x plus 3 over 2 plus 5. And that's actually not x. That should be a y up there. So then I'm going to go ahead and isolate my exponential. So I'll get x minus 5 is equal to e to the power of y plus 3 divided by 2. I'm now going to convert this to a log. So I'll have log base e of x minus 5 is equal to y plus 3 divided by 2. And again, a log of base e is the same thing as a natural log. So I can change that there. Then I want to go ahead and get y by itself. So I'll multiply both sides by 2. So I have 2 natural log of x minus 5 is equal to y plus 3. And lastly, subtract 2 from both sides. So again, in the end, my inverse should be 2 times the natural log of x minus 5 minus 3. And then the last thing wants to do is state the domain. So our domain here is going to be dependent again on our horizontal shift, which is going to be to the right 5. I don't have any reflections over my y-axis, so we're going to be going from 5 to infinity. Again, the 5 will not be included in the domain. So the domain of the inverse and then the inverse itself. All right, last two questions here. We're evaluating the inverse of g of negative, or inverse of g of h of 2 plus h of 4. So first I want to find h of 2. That's just going to be 5 times 2 minus 2, which is 10 minus 2, which is 8. So now I'm going to look for 8 on g of x, but since it's the inverse, it's going to be looking at the y value. So that's right here. So the inverse of that is going to be negative 3, because again, if we find the inverse of a function, we can essentially swap our x and our y values. So our first part here is going to be equal to negative 3. And then next, I want to find h of 4. So I'll plug that in. That is going to be 5 times 4 minus 2, which is 20 minus 2, which is 18. So our second part's 18. And again, I'm adding these together. So negative 3 plus 18 will just give me 15. So that will be my answer. And then lastly, finding f of h of x, if f of x is x plus 3 squared. So I'm going to be taking h of x, which is this, and plugging that in to x right there, which will give me 5x minus 2 plus 3, all of that squared. I do simplify inside the parentheses first, so that's going to be the same thing as 5x plus 1 squared. And when I multiply that all out, that should give me 25x squared plus 10x plus 1. All right, and that is how we would do all the questions on section 1 of the test review.